will tell you it is up to you. Sorry, what's more clean and crisp?
I said a rectangle looks more clean and crisp than a circle.
I agree. And actually, because of that reason is why I said this. So, two-column proofs are equally as useful, in my opinion, better looking than a flowchart. Because flowcharts kind of, to me, feel a little bit random. So, in whatever way that you want to organize your thoughts, yesterday we did a lot of discussion about, well, if this, then that, then that, then that, and yeah, now we got to write things down. So, sketch a quick little picture of this. Or, well, I guess you don't have to, but what do we see here with, well, and if we go alphabetical order like yesterday, we have two triangles, right? ABC, probably EDF if it goes in the right order.
No, it would be FDE.
Why is that?
Because it's the same order as the other one.
It has to be the same order.
Because the 6 to the 4.5, right? The 6 to the 4.5 and the 6 to the 4.5. So order would not be alphabetical for both of these. If we go ABC, it's going to be FDE. Are they congruent? Why did we say that? So how do we write this down then? How do we flowchart this?
We draw circles. And then we say AC is...
Wait, what's the question? So we say side...
Ooh, nope, we can't say side, side, side yet.
No,
Because we haven't talked about the sides.
I was going to say side A, B is 6 and side, whatever, DF is 6, or FD, whatever. Well, we can't say that.
Aren't two lines of equal length congruent?
Well, yeah, but we don't know they have equal length.
Isn't 6 equal to 6?
Yeah, but you have to write down first that they're both
The
are equal to 6.
measure
Then you have to write that 6 is congruent to 6, and then you need to write it.
Do we? That feels a little silly for mathematicians, in my opinion. What's necessary in a flowchart? Or more so, what's necessary in a proof?
It's true. True. It has to be true.
Has to be provable. What I was asking the question because I thought that's what you said. So, if we can all observe the same thing, do we know 6 is equal to 6? Does every person know that vertical angles are equal to each other? Right. So we can make certain, and it's not assumptions. Oh no, I'm missing a book. We can make certain allowances for people know this. So we do not have to say AB is 6, FD is 6, so AB is equal to FD. We can straight up just say AB is congruent to FD because that's observable in the given. Given? Yeah, so given things that we can just observe, like if we have parallel markings, if we have perpendicular markings, if we have vertical angles, we have to state that unless the angles have already been marked to be congruent. So vertical angles, we can't just we'd have to say, hey, these are vertical angles. But if they're marked congruent, then it's given, right? So since they don't have to be marked congruent with tick marks, we know 4.5 is equal to 4.5. So likewise, we can say BC is congruent to DE. And likewise, half rectangle, half circle looks like a bullet. CA.
Yeah, that.
EF. And then do we just go straight to our next circle? how do we know this and this?
Oh, well, we
And
have to
this.
put them together.
So these are all given. So if we were doing a 2-column proof, that would go in the right column, and we could have just listed all 3 of these things in the left column. So then we're going to say triangle ABC congruent to triangle FDE. I think is what you guys said. Yeah. How do we know that? Side, 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 which we have now made into a theorem. Does side, side, side have a converse that's true?
Wait, why would we get?
Oh.
So yesterday, right, when we talked about these theorems, we had our theorem graphic organizer page out. And we have side, side, side on our theorem graphic organizer, right? If all 3 pairs of corresponding sides are congruent, then the triangles are congruent. Would the converse be true? That if 2 triangles are congruent, then all 3 sides are congruent? Yeah, right?
So what is that? So then it's a biconditional statement, right? Or something like that.
I'm not sure. So side, angle, side, we made sure we had the included, right? Same thing with angle, side, angle. Before we start using these today, I just wanted to make sure that we all agree. Angle, side, angle needs to be specific, that the side is between the congruent angles. Now, order pretty much tells us that, as long as we keep track of our order correctly. The only thing to watch out for is in one triangle, they might give you the side included, and in the next triangle, they might give it to you not included between the same angles, right? Because with angle, angle, we really know the third angle, but if this side length changes, like swaps to a different side, just watch out. They have some trapdoors in some of these practice problems. We talked about as. Not the bat. This is as, like multiple A's.
It's
Right?
not spelled the same as that.
I know. Stop it!
Stop saying it.
All right, so did we have any other ones? Because I was pushing you guys at the end of class saying there's another.
Isn't there a hypotenuse leg theorem or something like that?
I don't know what you're talking about.
That's to do with right triangles, though.
That brings up a whole other if then. All right, you guys on your own. Flowchart for this one or 2-column. I don't care.
Cool.
What is something we would state?
QPR is congruent to angle RTS because it's
Yeah, if we want to give that, we can see it, but we could go ahead and say it. And actually, we could just call this angle P because it's on its own. So really, we could just say is congruent to angle T, and that's part of our given. So if we 2-column, we're going to have statement side and reason side, right? Statement and reason. Since somebody else said it, and this one we do have to use 3-point angle notation. I know I said on your own, but what that means is I'm not going to tell you anything. I'm just going to ask. Somebody else said it.
Wait, there? No. Okay.
Why do we have to use 3-point angle notation? You tell me.
Never mind.
What is 3-point angle notation?
This.
Or you put 3 letters instead of this one.
This is 3-point angle
Oh, yeah,
notation
yeah.
versus this is not.
Yeah. Okay. I didn't know it had an actual name.
Yeah. So PRQ. Perk. Spelled very awkwardly. What's it congruent to? Ooh, SRT. Ooh. Let's go in the same order. If we're doing PRQ, we should probably go TRS. It doesn't really matter, but it's nicer. Because then that would be the order of our triangles, too.
Drew them. I succeeded in making them.
And that, is that given?
No, it's vertical.
Ah, that's verticals.
Back.
Vertical angle theorem. Because guys, what you're claiming over here in these reasons, they got to be theorems. They can't just be stuff that we made up or stuff that we think. They gotta be theorems.
They have to be proved.
Have to be proven, right? We can't just make stuff up. What else?
T is congruent to TS because given.
Oh, we know that. So we could state that too.
And then you could do
Does angle side work? Yeah, angle side works. So we actually already know. So I'm going to sneak in. PQ was congruent to TS. Now we don't we can use that without writing it, but it's way better to just go ahead and write it. That was also given. So now, if I do my angles in the right order, that's my triangle order, guys. So if you care about order ahead of time, you make things a little bit easier. And because we said we all agree that angle side is a theorem now, we can use it.
I just put THM. Does that still make sense?
Yeah, it kind of looks like you're shortening the word them. Normally we shorten theorem with THRM. Any preguntas? What do you mean, oh?
I thought that it was going to ask if the triangles are congruent.
How many congruence statements would we need to write down? 6, right? So I'm not going to make you guys do this, but give me 2 sides that would be congruent.
Wait, I didn't finish reading the
Oh no.
problem, so.
Read the problem.
UV is congruent to XY.
Yeah, we take the same order as it's written. Or actually, give me 2 different sides that are congruent.
VW is congruent to Y.
Yep. Connor, give me 2 angles that are congruent.
UVW is congruent to XYZ.
Yeah, real tough, right? And we could even just say angle U to X, angle V to Y, angle W to Z. So we would have 6 congruent statements there. But I'm going to be a nice guy and not write them down. So Callie. Oh, Callie. So Callie is one of those middle schoolers who's halfway doing her homework.
Oh, yeah. Like,
She made a flow chart, but what is she missing?
She didn't write all the reasoning.
Yeah, there's no reasons. You guys want to help her out by writing reasons for her? You can go up there if you want.
wait, how would she know that?
Yeah, that's the whole challenge here.
Oh, okay. Well,
How does she know that?
why are you even
Can I go to the bathroom real quick?
Yeah, absolutely.
Why did she write it like that?
Now wait, don't the reasons go beneath?
Oh, right, yeah.
Can you do
Here,
the
hit the-
hand
hit the
thing
cursor.
here? Or no?
Hit the cursor up top and then just move it. Click your given and just
That's
move it.
cool.
Okay, this one's reflex.
What about AD parallel to CV?
Oh, that's
Oh, this is
That's
parallel.
given,
That's
right?
given. For some reason, I thought it said congruent. This one's reflex.
Civ property.
DD to DB. Oh yeah, it's the same thing.
It's just spelled bad.
It's really reflexive, just to say it out loud.
But if is such a boring word. What the crap?
Reflexive potty.
No, property. I know.
Normally we abbreviate that with prop.
Oh, okay.
Does the hand thing work on this smartboard?
You have to turn it to eraser. So no, not really.
ADB is congruent. Ooh, CBD. Oh, that's that would be
This one and that one.
AIA. Hey,
Okay.
right? I don't even know where Jake went. I guess I
He
should
went to the.
Do we have parallel lines with a
Wait, what does
transversal?
AIA mean?
What is
Oh,
AIA?
alternate interior angles.
Ah, so
That's what we learned in Math 1 last year.
no. I'm gonna fix that because Miss Tecklenburg should not. Oh no, that was Mr. Hall. That's way too abbreviated. If we're gonna abbreviate that, what we're gonna do? Because there's
Alt,
two.
int, and then angle.
There's too many abbreviations.
Alt,
So
and
alt,
then int,
int,
and then angle.
angle.
Oh.
So we gotta. I know, but there are
But
too
that's something
many
no one
things.
understands.
You can't abbreviate with just one letter. There are too
Wait,
many things
why
to
is
abbreviate.
this down here?
That's the end.
Oh.
Wait. So
Wait,
that-
A, D, B, C, B.
That's two angles.
Let's go ahead and draw that.
Oh, it's
right? Let's mark those angles.
drawing.
So here and here.
Yeah.
And then also the line in the middle should be.
Yeah.
So
Oh yeah, to itself.
So then that would be with the two A's. The one with the two A's. 'Cause
Or
angle, side. Side.
can we do side angle side?
Side angles.
No. I don't think so.
Why can't we?
Because we only have one side.
Yeah, don't fall in the trap. CB, DA, not congruent. At least we don't know that they're congruent. They're parallel. Be careful thinking that the parallel marks are also going to provide us some sort of congruent. When would AB be congruent to BC?
If AB was parallel to DC.
Yeah, if we had another set of parallel lines, right? So then, all right, so would go under that, but then what goes under AB congruent to? Wait, crap, that's what I just asked you guys. Is AB congruent to CB? And we said no, but now they're saying yes.
Well,
that's
we
because
don't
we
know.
proved that they're congruent. So that
It's not that they're expressly not.
they're side.
Apparently, we do know now because they
Well,
wrote it down.
Now we do. Well, because corresponding angles theorem, or whatever
Wait.
that one's called, or corresponding sides.
Corresponding.
They are corresponding though.
I think you're remembering the theorem, but you're not remembering the name.
Like,
Wait, don't we already know the triangles?
it's like
Yeah.
corresponding angles and sides.
So correspond CPCTC, something like that.
It is.
Yay!
Grab a seat. Grab a seat because we gotta write this
Got
down.
it right.
It is. This is angle side.
Wait, so we're allowed to shorten that with just one letter.
Well, yeah, because we have made agreements that this theorem we can say is AAS. Guys, grab a seat. CPCTC.
Corresponding parts of congruent triangles congruent.
So it is not like when we say corresponding angles and they have to be in the same location. This is corresponding parts of, what's this word though? Congruent triangles are congruent. I don't know why this C tends to throw people off. Because a lot of what I say to you comes from having taught this for 10 years. And like, we do CPCTC and then I ask people, what does it mean? And they're like, corresponding parts. I'm like, what we're talking about is congruent triangles. So as soon as you claim your triangle's congruent, anything else, any of those 6 statements that we didn't write down, any of those, all of those can be claimed from CPCTC. As soon as we know this, CPCTC lets me claim all 6 of those statements.
I think it's called corresponding parts of congruent triangles.
Yeah, there's an of in there. Like US of A, yeah.
Because that may be why people get tripped up, because the of isn't shown.
Yeah.
And the
But
of-
often they actually just think it's corresponding also. They're like corresponding parts of corresponding triangles. Like, whoa, what are corresponding triangles? Like triangles talking to each other? Like they're corresponding? Alright, so challenge 1. These ones are harder than the ones we've done, so I'm going to give you guys some time to chat with each other and not with me. You can scroll the screen as you want to.
So we're gonna do all of them.
So there's that one down there that you can't quite see right now. Aside from that, you can see most of it.
We should start with C. We are?
Oh wait, what are we doing?
Are we trying to prove one congruent?
Determine whether the triangles are congruent or not.
Oh, okay.
You can do 2 column though.
Oh, wait, we need to do like a proof?
Yeah.
Oh,
You gotta prove the triangle's congruent.
well, we can say the sides are parallel and the things are congruent. And we can also say that.
So somebody should write this on the board. You guys said DC is parallel to AB. Parallel.
I know.
To a,
Oh, yeah, we got that.
and then. Okay. Oh wow.
Wow, Jake. Not working as a team.
Because of me.
Reflex, yeah. Wait, the first one's because.
Jake has very little patience. Alright, Jake, start thinking about the next one then.
Alright.
Don't write anything down, but you can even sit in my chair if you want. I don't care. Hey, don't write anything down yet, because let everyone else
As
think
Jake said,
And then.
Bach is congruent to.
Okay, then you write it down. I can't.
Okay.
So it really doesn't matter what things look like, does it?
No.
So looks are way deceiving.
Yeah.
Should be capitalized.
I agree with everything you guys had from A. Let's look at B. So I might just clear the ink real fast, unless you want to do the eraser thing. You want to do the eraser thing?
Eraser, my turn.
You can make it
Did
bigger
last
or
time.
loop it, yeah. So I think what Jake already drew is kind of the obvious point out of the vertical angles. Let's everyone take a step back for a second. So let's share ideas before we all start drawing at the same time. So we've got vertical angles, but after that, we would have all 3 angles, right? But where do we go from there?
Wait, how would we have all 3 angles?
Angle is really angle. You tell me how we would have all 3 angles.
Yeah. Okay. Yeah.
Triangle angle sum theorem, right? So our reason for that would be triangle angle sum theorem.
I don't understand.
I don't
had
think
something
that
for a
I'm
second, but then I forgot what it was.
You have to be able to tell me why you say what you say.
Wait.
Can you finish? Yeah.
Oh, for that one. Okay.
Yeah, I got nothing.
I don't think.
You want to
We
go ahead
have
and
the
mark
third
F and J? Since we know F and J, go ahead and mark those.
Oh, well,
F and J are congruent.
actually, we know they're
How do we know that?
not.
Because of
Triangle angle sum theorem.
Ah.
Because vertical angles and the 50-degree angles.
Are you gonna put 3?
That's a lot of lines.
Looks like an ice cream
Well,
cone.
we know they're not congruent. Okay, next problem.
Wait, whoa. What do you mean we know they're not congruent?
Well, because we know that this is corresponding to that, and those are not the same number.
Okay, but you gotta have a reason.
They're not the same number.
What's the mathematical, what's the theorem?
Is there a theorem about that?
Or a converse of a theorem, probably, quite maybe.
Probably crazy.
Well, wait, we need to write it down. So F is wait, actually, we need to start with.
What? So hold on, let's play out the what ifs. If the triangles were congruent,
Then JI would have to be 5.
JI would have to be 5, or FG would have to be 4.
Yeah.
So, can we use that to say that they're not?
Yes.
What theorem did we talk about that relates angle size to
Oh, the hinge there.
the hinge theorem? This is the converse of the hinge theorem.
Wow.
Because if 2 triangles are congruent, then we can relate that 2 legs will be congruent from their congruent angles, right? That the opposite angle relates to it. So from the converse of the hinge theorem, we can say that because this angle is congruent to that angle, but relates to 5 and relates to 4, these triangles are similar. Right? So we can definitively prove they're similar, but hinge theorem tells us that's all they
Because
are.
all their angles are the same.
because all their angles are the same. Try the next one. You want to scroll down?
Of course he does.
That one looks real funky, but we learned that what it looks like doesn't matter.
I don't like it. It doesn't make sense to me.
And then you could use the Pythagorean theorem to find
No, they're not congruent.
Well, 6 isn't congruent to 2.
Yeah.
But
They're
I don't know
similar.
what the thing is, but 6 would have to be equal to 2 for them to be congruent.
No, the 6 would have to be the 3.
No.
Oh, no?
6
Yeah.
would have to be congruent to 2.
Yeah. They're similar.
Well, are they similar?
Wait.
I don't think they're similar. I just don't think they're congruent.
Yeah.
They're both a right triangle. But what's the thing? The theorem thing. Don't erase it. We still need it. Okay.
They're not congruent.
Well, yeah, but why?
So, I'm surprised nobody even said this on the last one. Do we write out proofs to not prove something? Like, if the triangles are like garbage, do we write out a proof?
No.
We just say, like, get out of here, right? So, like, me, I just like the hinge theorem. Sorry, it's like a personal thing of mine.
Yeah,
So, we, like, up on B, we don't need to write out a proof. You just say they're not congruent. Now, you do need to give a justification. So, like you guys said, G whatever to I whatever. Like, you could say that. So, down here, be careful, though. For C, what relationship did you say is supposed to happen? What side to what side?
TV and
TV to either TU or SU.
No, you can't say either.
TV to
Because you know two sides of two triangles. You can make the relationship.
It has to be TV to SU.
Yeah. TV
But
and
it's
SU.
not.
Not correct.
No, it's TV to US because this is I think.
No.
Wait, no. UTV. No, wait, I'm messing this up, aren't I? Okay.
That's not a
Poor
side.
Fabian.
Wait.
Long leg, short leg, hypotenuse. Long leg, short leg, hypotenuse. 6 would go with 3, or 3 would go with 2. You gotta relate short leg to short leg, long leg to long leg. So if we're gonna make a justification for why these aren't congruent, you could go short leg, right, and say SU is not congruent to UT, or you could go long leg to long leg, which is long leg, right? So we're looking at the two different triangles. Okay, so over here, still right triangles.
Pythagorean theorem. Yeah.
Well, it's easy. All we have.
No, it's fun. You don't.
It's
because
12
it's
squared
a
plus 5
math-
squared equals 13
It's
squared.
famous.
Yeah, it's the
This is a famous triangle. I got its
It's a famous triangle.
yeah, I got its autograph at a convention last year.
Well, so 144 plus 20.
No, these are the. What are they called? I forget what they're called.
Pythagorean.
Triple.
Boom.
Yay! Okay.
This is a Pythagorean triple triangle. 5, 12, 13 is a famous right triangle.
It is.
What the heck?
Yeah, 5, 12, 13 is a famous right triangle.
Yeah.
So I would
it's
assume 13
3,
squared
4,
equals
5, and-
169.
So, wait, I have a question then.
It does.
Okay.
If
Okay, we don't need.
if you only, let's play out a big what if. Grab a seat. We're gonna play out a big what if.
Big one is.
Ooh, but I'm gonna erase all this. Because then I'm gonna tell you don't know these things. If all I told you,
Can you erase the little guy right there? Yeah, thank you.
so what if you didn't, like, you had the 5 here and the 12 there. What if you didn't have this 5 and you only knew this 12? And you also didn't know this?
You couldn't prove that.
I think
We can't?
you could.
Angle
Let's
on
see
the
what's
side would work, right? Or
Angle
Oh,
or-
yeah.
No, it's angle side side. But
Yeah, so it's angle side side, right? Which is
Wait, but it's a right triangle.
So you can use
Okay.
hypotenuse.
No.
what the heck are you talking? I don't know what you're talking about.
What's the hypotenuse leg again?
Hypotenuse
the HL theorem, I'm pretty sure
Yeah,
if you have a right triangle and you know two of the legs, then it's congruent to the other one.
Why?
It's if you know the hypotenuse in the leg and that it's a right triangle. Is that what it is?
It's like a different way of
Now,
side.
if you know that it's a right triangle
Or-
and you know
No, it's
the
a different
hypotenuse
way
of
of
one leg.
side angle. Yeah.
It's
That's what
but
Tecklenburg said. She said it's a
Let's
different
back away from right triangle for a second. When we know two angles of a triangle, why do we know the third angle has to be congruent?
Because a triangle angle something.
Triangle angle something, right? So if we have two triangles that we know are right, and we have two legs, can we say that the third legs have to be congruent?
Yeah.
How?
Well,
I don't know.
because we know,
We have to answer these questions.
like, you know how
Because Mr. Hall said so.
you know how with hinge theorem we were talking about how it could. I think it was with hinge theorem. How like it couldn't be 180 or 0 degrees. The angle that we know is 90 degrees. Or actually, wait, no, never mind. We don't know that angle. We know the hinge. We don't know the other. We don't know the door. We know the door frame and the. We know the door frame and the door. We
You're
don't
not
know.
making sense.
If I give you the 12 and the 13, is there a range for the third leg?
Yeah.
Yeah.
One.
A range?
Alright.
Like,
It has to be greater than 1.
I think you guys are
There's
forgetting.
only one possible thing it can be because if you open up any wider, it can't connect.
Why?
Physics.
What type of triangle is this?
Right triangle.
So, the fact that right triangle is given, right? We said these are right
So the
triangles.
12 is fixed, so the 12 can't move. But the 13 is the only thing that can move. And if you don't know the side, then it can only move just way.
Can the 13 move?
No,
No,
because
because then it wouldn't be a right triangle.
it has to intersect with that line up there.
Guys, what were you gonna use to get the third leg length?
I thought it was like,
No, we don't know that yet. Pythagorean. Guys, Pythagorean is like the triangle angle sum theorem, but for legs. Right? If you have right triangles, you're operating under a specific set of rules. Right? Like, what's the angle of a square in every corner?
90.
Because it's operating under a certain set of rules. Right? Like, what's the angle in any polygon at the interior corner? Well, that's hard to figure out. Depends on the polygon, depends if it's regular. This is not an any triangle situation, right? This is a right triangle situation. So the hypotenuse leg is an adaptation of the bad word. So we can't use angle side side. However, if we have the right angle, one of the legs, and the hypotenuse, we now have a new theorem. If you want to grab your theorem graphic organizer page,
This is what we call hypotenuse leg.
this is hypotenuse leg theorem.
Haha, we proved
So it
it.
does exist.
Well, yeah, we
You made it.
about
You're
it last year.
gaslighting us, making us think it did exist.
The justification would be both ML and PQ have to abide by our right triangle rules, which tells us, well, that third side is the square root of a squared plus b squared. What really is this formula?
Pythagorean.
Yeah, but there's another name. There's another way we use this. I just want to make sure you guys know this.
Oh, I remember
It's distance formula. When you derive it down to the length of one of the lines, it's the distance formula. So this is a modification of Pythagorean theorem. So it still is like a derivative of it, right? Because we just did algebra. But this is actually the distance formula.
Is that like the explanation of why the theorem works?
Yeah. Because these distances are fixed because they have to operate under a certain set of rules.
Wait, what?
And then, I think this will answer your question. And then, if this has to be true, what we really have is side, side, side. Right? Hypotenuse leg is really getting us to side, side, side. But we just can skip over the math. Because we know it will always work out as long as your hypotenuse and your leg are congruent to the other triangle's hypotenuse and leg. Preguntas. Kind of cool, yeah. It lets us save time. It actually lets us skip steps. So we know reflexive property really well. Who, what?
Wait. How can you know reflexive property really well?
We know a thing is equal to itself. I think we know that pretty well.
Yeah.
So reflexive. We're good with reflexive. Here's what I want to talk about. Symmetric, which means it goes both ways, right? A to B, B to A. This is where people get confused, is the transitive property. So, and I can't tell if I have Jake or not. Transitive works in a few different ways. You can also use it with inequalities. So if A is greater than B and B is greater than C, then A is greater than C. Right? This is really, what is transitive property really kind of just doing? What else do we call it when we... Substitution. Well, funny. Kind of. This is really the substitution, right? We're substituting in if A equals B and B equals C. Well, then really I can substitute B for C and we're off to the races.
Ooh, how much you betting on the...
I have no money to bet.
Really?
I mean, I probably could if I wanted to, but I don't want to. You got 4 minutes to work on homework.
Can you play music?
I probably can, but probably only one song. Somebody has one of my pens.
Oh, wait, the question's up
I
there.
think Jake.
No, my pocket has one of my pens. Sorry.
Oh yeah, we're gonna make a couple doodles.
Could you freeze the screen so we
Connor, do you want to see my
Yeah, I'll just leave it right there.